கேக்குது.
Ma'am, good morning, ma'am. Shall I start, ma'am?
Okay, sir.
Okay. Good morning to one and all present here. It's a wonderful pleasure and it's a grateful opportunity to inaugurate our college in virtual lab. And I also thanks to our management. And I also warm welcome to our beloved management and beloved principal, the respected principal and the respected various department HODs and my dear colleagues. It's a wonderful opportunity to do the virtual lab inaugurate in our college. And I also welcome to our NIT Surathgal team to support for the virtual lab and a beautiful inauguration. We welcome, ma'am. Now the session is yours, ma'am. Thank you, ma'am.
Thank you, sir.
Oh,
Very good morning to an and all present over here. Myself, Shrestha, working as Senior Research Fellow at Center for System Design, NIT Surathgal. Hope my voice is clear and audible, sir. Hello.
hear me, ma'am. Hear me, ma'am.
Thank you, sir.
Yes, ma'am, it's audible, ma'am.
Thank you, sir. I welcome you all for this introductory webinar on virtual labs on behalf of NIT Surathgal Virtual Labs team. So let me share my screen now. Okay. So today, since it's an introductory webinar, first let's see what exactly is this virtual lab in brief. Then let's see how the platform is, and then few examples in different domains of engineering. In simple terms, as the name itself indicates, virtual labs, it is computer-based labs, which is an MOE Government of India initiative under National Mission on Education through ICT. So when I say national mission, it is an umbrella mission which takes care of various ICT initiatives such as Swayam Prabha, Virtual Labs, Yantra, FOSSI, and so on. So Virtual Lab is one of the ICT initiatives which was started long back around in 2008, and it is still an ongoing project. So before moving into what are the features, what exactly it is, how it works, why government might have started this project called virtual labs. So there are many reasons behind that. Few factors, as you can see on the screen. We know the number of colleges are increasing, also the number of graduates. But what about the standard? They may not be reaching the industry expectations, right? The reasons may be again many. Some institutions might set up research centers within the institute, but what about the condition of college that is located in remote areas? They may not have good communication with the industry people. Also, We know to set up individual lab, the cost involved is very huge, right? So what about the condition of college that has just started with? The labs may not be that well equipped. Also, we know some of the component cost very huge amount of value. So it would be better if components could be shared between the institutions. So in order to facilitate all these requirements and also in order to establish equality among students of different institutions, Government of India started a project called Virtual Labs. So it is basically to provide remote access to n number of users to a lab or experiment through internet. So basic structure of virtual labs would be very similar to our physical lab. So in different domains, we have set of labs. So virtual lab, when I say, it is not just dedicated to one domain. No. Similar to what we have labs in different departments. Likewise, here as well we have different domains, and inside each domain we have set of labs. And each lab contains set of experiments. Okay. And this is not developed keeping in mind with just one syllabus of any one university. No, across the country, looking into the wide variety of syllabus from different universities, this is being developed, and it is still more and more labs are getting developed in wider areas. So basically here, n number of users at a time can work on individual experiments through internet. Moving with its features, first important point which we need to remember is virtual labs are 3P labs. That is, it is independent of place, pace, and period. Starting with the period, time independency. Here, unlike physical lab where usually we have a time restriction between 9 to 5, here it is not having a time limit. Early in the morning or late at night, whichever time user is convenient with, he can work on these labs. Next is place independency. Again, user need not come to physical lab itself to work on these labs. At his home, hostel, classroom. So whichever place he is convenient with at that point of time, he can work on these labs. Next is pace. Pace is speed independency. Some might be a fast learner, whereas some might be a slow learner, right? We know it depends on individuals. Some might complete multiple experiments within given 2 or 3 hours of time, whereas some may not even complete a single experiment. Since here individuals work on different experiments, it is speed independent as well. So it is anytime, anywhere lab. And how can we achieve this? Then what is the requirement to work on these labs? So there is no as such requirement, specific requirement. We just need a computing device with the internet connection. So when I say computing device, again it could be a desktop, a laptop, or simple mobile phones. Okay, and these virtual labs are free to use, and it mainly stresses on self-learning. So here there need not be any supervisions required, and how self-learning is achieved or promoted. Here we have complete learning management system at a single point with respect to any of the concept. So that is the last point, one-stop resource availability. So when you explore the platform, you can come to know that if you take any of the experiment, similar to what students write in their record book for each and every experiment, maybe aim, apparatus used, theory behind the concept, procedure, experimental table, graph. So all these things for most of the experiments would be available at single points. Okay, and the contents also would be verified ones, and these contents will be available along with few more additional contents such as some of the questions relevant to the concept to check one's understandings. Some In some cases we might have manual to be downloaded available, animated demonstrations available, and so on as well. Okay, reference links. All these things will be available at one point. So moving ahead with the types. Based on scalability and closer to reality, virtual labs are classified into three types. First one is simulation based, second one is measurement based, and third one is remote triggered type. Simulation based labs are mainly based on mathematical modeling. Next is measurement based lab. So here, developer of the lab would have priorly conducted the experiment and the obtained data would be stored in the server. So whenever user performs the experiment, he will be getting the stored data. Whereas in third type, that is remote triggered type of virtual labs, user himself can trigger the actual experiment. Okay, user himself can trigger the actual experiment remotely, see how it works, and get the real-time data as output. So, for example, if an experiment is kept at NIT Surathgal experimental setup, then you sitting at your own place can trigger the experiment remotely, see how it works through live feed, and then get the real-time data as output for further processing. So that will be more closer to reality, and so we have only few remote triggered labs available. Whereas simulation based, there are 1000 plus simulation based experiments available across the platform. Then the difference between physical lab and virtual lab. Some factors we already discussed. Cost, we already as discussed, the only requirement is a computing device with the internet connection, so the cost involved is almost nil. Availability, since the mode is virtual, this is available all the time. Experimentations, again, since we work online, here there is no boundary limitations as what we have in our physical labs. It provides wider and safer options to do innovative experimentations. In terms of user experience, virtual labs stands the second best. And we need to remember one thing, virtual lab is not just an alternative to physical lab. No. It is basically an experiential tool, or it is a tool to provide experiential learning of concept. And when I say concept, it could be a theoretical concept or it could be a practical ones. Okay, so it is not just an alternative to physical lab. Moving ahead is the different domains. As I told earlier, in these different domains, we have virtual labs available, 7 engineering and 2 basic science. Recent development is going on in the fields other than these as well. And who developed these labs? Is it just NIT Surathgal? No. So there are 11 participating institutes entitled to the project, 6 old IITs, Triple IT Hyderabad, 2 private universities, NITK Surathgal and COE Pune. So NITK is the only one NIT involved in this particular project. Okay. So NITK is the only one NIT involved in this particular project. So all these institutes would be involved in the development as well as outreach activities. IIT Delhi is the national coordinator of Virtual Labs project. And at NITK Surathgal, there is a transdisciplinary R&D center which takes care of this initiative along with others. It is Center for System Design. It is a place where people from different domains will come and work on wide variety of projects. It is headed by Professor K.V. Gangadharan, who is professor in the Department of Mechanical Engineering, and lab development is coordinated by Dr. Prithviraj Umesh, who is an assistant professor in the Department of Water Resources and Ocean Engineering. These are the different areas where we work on. We work here on UAV-based projects, sound and vibration related projects, smart metal application based project, product development based, experiential learning based. So virtual lab is an example for experiential learning type of project. Okay, and at NITK Surathgal, virtual labs work with the name SOLVE, that is Student Online Laboratory for Virtual Experimentations, SOLVE. There are currently 360 plus nodal centers entitled under NIT Surathgal to this virtual labs initiative, and main area of development of NIT Surathgal virtual labs team is in mechanical engineering, civil engineering, chemical and electrical engineering. And whatever activities we do here, we'll be updating in our social media handles. So in Facebook, we have two pages, csd.nitk, sol.nitk, that is Center for System Design at NITK Surathgal, and Sol, the virtual lab at NITK Surathgal. Instagram, we have two IDs again, it is csd_nitk and sol.nitk. So you can note down these things. Whatever activities we do here, internship opportunities, everything we will be updating here only. Other than these four, even in YouTube, we have a channel called Center for System Design at NITK Surathgal. You can look into the videos available over there as well to see what we do here. And Lagupata is one such video tutorial series to guide user with the usage of virtual labs, and this Lagupata is available for most of the labs developed by NITK Surathgal. So this was an overview of what exactly is this virtual labs. So in short, it is basically a journey from concept to reality. Here we stress on do engineering rather than just read engineering. Okay, so keeping these things in mind, now let's see how the platform is. So for that, we need to remember one thing. Virtual lab is not a software, it is a website. And the link to access Virtual Labs website is vlab.co.in. So I'll share my screen again. In a browser, in a tab, we need to type a link vlab.co.in. So this is the homepage of Virtual Labs. These things we already discussed, so you can go through that later. Then these are the broad areas in which virtual labs are developed, and these are the participating institutes. So before getting into the labs in different domains, let's think, or let's keep in mind few points. So first thing is, we know some of the concepts are common between different domains, right? Say for example, logic design or digital electronic concepts is common between circuit and IT domain, whereas strength of materials lab similarly is common between civil and mechanical engineering domain, right? So here, when we are searching for a concept of our interest, then we need to look into our relative domain labs as well. Okay. So if you are looking for a concept from logic design, then we need to look into the labs under electronics and communication as well as computer science and engineering domain. So in general, if you are searching for a concept from circuit domain, then look into the allied domains as well: electronics and communication, computer science and engineering, electrical engineering, and physical sciences domain labs. Similarly, mechanical engineering and civil engineering share some of the concepts, chemical and chemical sciences. Okay, so one thing is this one we need to keep in mind. Second point is, some of the concepts would be demonstrated under multiple labs. So whichever interface we feel convenient, we can pick that as per our requirement. In some cases, some of the simulation of any of the experiments might be under maintenance. So you need not worry on that. You can look into the other labs for similar experiments. Okay. And one more thing, if you don't find a lab over here, then there is one more website which has few more additional labs that are not found over here. So for that, we need to scroll down, and here you can see a button called VLabs Dev. So even that website has many more labs which are not available over here. Okay, so let's see one by one. To familiarize you with the structure of a lab and experiments, let me take you inside a lab under electronics and communication, one of the basic lab. So if you see any domain, you'll find list of labs as you can see over here. These are the institute that has developed respective labs. Okay, so we have labs from basic topic to advanced ones. We have older labs and newer labs available inside each domain. Okay, so getting into a lab, I'll start with basic electronics lab. So I'll take you inside few of the labs from circuit domain. Then the other team members of NITK virtual labs will take you with the other domain lab demonstrations. Okay, so I'll take you inside circuit domain. So I'll start with one of the basic lab, and I'm into basic electronics virtual lab now. So as I told earlier, if you take any of the lab in this virtual lab platform, these would be the general contents covered. You would be having introduction for the lab, then the list of experiments inside each lab, instruction, technology used, people behind the development, and the feedback link. Okay. If you find any error, or if you feel difficult to do with any of the experiments, you can directly contact these people as well to clear your queries. Okay, so this is the list of experiments. We have 17 experiments available under basic electronics lab, and we need to remember one thing. The number of experiments is lab independent. That is, some lab might have 17 or 20 plus experiments, whereas some labs might have just around 10 experiments. Okay, so number of experiments are lab independent. And when I say experiment, some could be a completely theoretical based, whereas some could be experimental based. So here first three are theoretical based, explaining the concepts of R, L and C, whereas rest are experimental based. And when I say experimental based, again it varies in complexity levels. Some might be very simple, explaining the concepts, whereas some might be slightly complicated one, providing the hands-on experience. Okay, so let's take one of the example, Ohm's law, which irrespective of the domain we all would be familiar with. So this is the experiment I have chosen, and again, as I told earlier, most of the contents are available. So we have detailed theory behind the concept available. Then we have procedure. So we need to remember, in most of the cases, this would be the procedure to do the experiment in this virtual labs platform. Okay, next is quiz. Set of questions to test one's understanding levels. So this we can solve using pen and paper, answer and verify our results if it is right or wrong by clicking the submit button. Okay, then we have assignment questions, few more questions to solve. Then we have reference links. And simulation is a tab where we do the experiment. And again, under Ohm's law, we have many variations based on complexity. So let's take the first one, a simplest one. And this is how the simulator interface available for Ohm's law experiment. And again, simulator interface differs from the experiments from each lab to lab. So most of the experiments within a lab will have similar simulator interface. Okay, some might have different types of interfaces. So Ohm's law experiment now, how to proceed with the experiment. In physical lab, if we take Ohm's law experiment, what we will do? We will ask students to take a resistor of some value, complete the connection using other components, then increase input voltage in steps. For each of the input voltage, note down the current or input-output values. Once we have sufficient readings in the table, go for plotting the graph. Right? So this is what we instruct students to do. So similarly, here we have instructions available. Then we have controls to vary the input or to provide the input. Then we have experimental table to be updated, graph to plot the graph. And here we have the circuit. So this is one of the simplest interface where the circuit is already rigged up or the circuit is fixed. So this is the basic case where the circuit would be fixed. We just need to vary the input parameters and note down the output variations. And this is mainly for understanding purpose. Okay, some labs we have which allows us to rig up our own circuit and proceed forward. That we'll see later on. So here, first step as per the instruction is to set resistance value. So we have a slider. I'll set to some arbitrary value. Now increase DC volt from minimum to maximum. So start with the minimum value, click on add to table. Okay. So for each of the DC volt value, click add to table. You can see table being updated. Okay. So once we have sufficient readings in the experimental table, you can click on the plot graph button to get the graph in graph area. Okay. So finally, I can click on this print button to get the printout of entire simulation window. So this I can save it in PDF format along with the date and time. We can save the entire simulation window in PDF format and keep it for a future reference. So we have one more button called clear. If I click on that, everything will be reset back. I can fix some other value of resistance and redo the experiment and get one more graph and compare both the results. Okay, so this is one of the basic experimental interface available. Moving back. Now, if you see the other labs over here, we have many labs for digital electronic concepts. One of the basic lab being hybrid electronics lab from COE Pune. Other than that, we have digital electronics lab 1, digital electronics lab 2, digital applications lab, digital logic design lab. Okay, so many labs are available for logic design concepts. Next would be circuit solving. So we come across many theorems and laws in our curriculum, right? Thevenin's theorem, Norton's theorem. So for that, again, we have many labs. One is this analog signals network and measurement lab from IIT Kharagpur. Okay, so we have plenty of experiments available within this as well. You can explore the simulator interface later on based on the procedure. Okay, so we have theorem based experiments, also measurement based experiments available within this particular lab. And other than that, we have one more lab, virtual circuit, electric circuits lab under physical sciences domain for the concepts of theorems and laws. Okay. Other than that, we have many labs for signal processing. So one is digital signal processing lab. Then we have signals and systems lab. Okay. So these are few of the labs available under electronics and communications domain. Then if we take electrical engineering. So as I told earlier, each lab will have labs that are core for that particular domain and also common to the different domains. Okay, so we have electrical machines lab, 3 electrical machines lab available, one from COE Pune, one from IIT Guwahati, and one more from IIT Roorkee. Then we have virtual high voltage lab, substation automation lab, PLC based lab, industrial electric drives lab, and so on. So if we take one of the experiment from electrical machines lab, newer lab, so older lab structure you saw in basic electronics lab, and newer labs will have structure like this. So the contents, similar contents would be covered, but all the tabs or subsections would be shifted to the left corner. Okay, so we would be having introduction for the lab, then objective, list of experiments, target audience, course alignment, that is syllabus mapping, and the feedback link. Okay, so moving into the list of experiments, here we have 8 experiments. First one here as well as theoretical based, explaining the components used in physical lab. Rest are experimental based. Okay, so taking you with one of the experiment, I have taken speed control of DC motor by field resistance control experiment. Again, here if you see, the contents covered are similar, but we have all the contents shifted to the left corner. Okay, and here in the newer lab experiments, we have quiz section divided as pre-test and post-test questions. Okay, this as well again we can answer and verify our results if it is right or wrong by submitting the quiz. Other contents are similar: aim, theory, procedure, references, and the feedback. So going into the simulation, this is slightly different, and this is how it is viable. So here, what additional thing? We have all the components in place. First step is to rig up the components or connect all the components as per the instructions and then move ahead with the experiments. Okay, so this is again not very complicated one. It will not allow to rig up our own circuit, but it gives more hands-on than the earlier one, right? We have all the node values given in blue color. Okay, we need to connect first. So quickly, if we do the connection A to K, A to Y, and A to J, A to K, A to Y, and A to J, B to P, E to M, F to D, G to R, H to I to C to H, and finally it is Q to L, right? So I'll do the connection, but if I connect something wrongly, the next step is to check if the connection is right or wrong by clicking the check button. And I get a pop-up message stating the connection is incorrect. So what next? I need to redo the connection. But how? How can I remove any of the wire? If I click on reset, everything will be removed. So to remove any of the wires, I need to click on the node names. Okay, so if I click on Q, this particular connection will be removed. If I click on I, all the three connections will be removed. So I'll click on Q and remove the connection and read the connection to Q to L. Next step is again check if the connection is right. We have a pop-up message stating the connection is right. Next is turn on MCB and now provide input. For that we have two sliders, field resistance and armature resistance. So first set voltmeter reading using second slider. Okay, now vary field resistance slider in steps. For each value, click on add to table to note down current versus speed reading. You can see the front view of DC motor. So once we have sufficient readings, we can go for plotting. Okay, so this is one more type of interface that is available. I can click on this plot graph button and now I can click on the sprint button to save the entire simulation window. So this is one more type. So analog electronics lab we have under electronics and communication with experiments having a similar flow. Okay, so you can explore the other experiments from electrical machines lab. Now moving back, as I told, even under physical sciences domain, we have solid state physics virtual lab, electricity and magnetism virtual labs, uh, one more lab, electric circuits lab and all with experiments relevant to circuit domain. Okay, so and if you try opening any of the experiment from Amrita Vishwavidyapeetham. So if I take one of the experiment, a random experiment I'm choosing. So all the contents are similar, but when you try to access the simulator, it asks for login. Okay, for some of the simulators developed by Amrita Vishwavidyapeetham and IIT Kanpur, when you try to access the simulator, it asks for login. You need not worry on that. You can freely sign up, create your account, and using the login credentials, you can keep on using the simulator whenever required. And some of the simulators, older simulators, would be depending on some of the basic plugins, such as Java or Flash. So we know Adobe Flash is currently blocked by the browser, right? So in order to use the experiments that are Flash independent, you can refer to this documentation available under announcement section, which guide you with the detailed step-by-step procedure for using Flash-based labs. Okay, so these are few of the points. And as I told earlier, one more website, that is New Labs, VLabs Dev. So here, this is the website maintained by IIT Bombay. Here at the top, we have option called Explore Labs, and that have three sub options. Here, approved labs and labs under development. So if I click on both, I'll get list of labs. These labs are not available currently in the main website. Once the lab is approved and complete with all, in all respect, it will move to the main website. Okay, until then you can access the experiments from here only. So we have 8051 microcontroller lab available only under approved labs section. And similarly for labs under development, here we have many more labs for many of the domains. So for example, integrated circuits lab have interface different than the earlier ones. So here we have op-amp based experiments. Okay, so here if you see the simulation, this is how the interface is. We have work area, we have components. Okay, so first I can get each of the components to workspace, provide components its value. Okay, so we'll get a pop-up to enter value for each of the components. So once I get all the components similarly, I can connect each of the component using connect option. I have option to move, undo, clear. I can then get CRO to workspace, connect input and output to CRO. Then I can turn on the simulation. If the connections are complete and correct, all the connections will turn green. Okay, so all these connections which are done in blue color, everything will be turned to green color, and then you can see input output by clicking the show graph button. Also you can see the frequency response. So this is one more type of simulator available. You can explore different labs available relevant for circuit domain. Okay, similarly computer science and engineering have many labs such as computer architecture and organization lab, computer organization lab, image processing lab, VLSI lab, all relevant to circuit domain. So with this, I'll stop sharing my screen, stop the presentation from my end, and hand over the session to my colleague Akshaya, who will be taking you with the labs under computer science and engineering domain. Thank you. Over to you, Akshaya.
Thank you, Shrishna. I hope my voice is audible.
Yes, ma'am, audible.
Good morning, everyone. Myself Akshaya, and I'm working as Junior Research Fellow at Center for System Design in NIT Surathgal. So I'll be taking you through the computer science and engineering labs available in virtual labs. Let me share my screen. I hope my screen is visible. So to explore labs available for computer science and engineering, we can click on the link under broad areas of virtual labs. That will lead to a page listing all the labs for CS. So we can see here around more than 20 labs have been listed, developed by different institutes like IIIT Hyderabad, IIT Kharagpur, Kanpur, IIT Guwahati, etc. So for the demo, I'll be choosing one of the labs, that is data structures. And for data structures, we have 3 labs available developed by IIIT Hyderabad. I'll go with one of them, that is data structures 1. This is the page for data structures 1, wherein we can see introduction to the lab, objective, and a list of experiments. We can see experiments related to sorting, graphs, trees, stacks and queues, searching and linked lists. And there is target audience, course alignment and feedback. So under list of experiments, I'll go with stacks and queues experiment. This is the interface for the experiment, wherein we can see aim of the experiment. Under overview part, we can see a short video explaining about the sections available here, and also prerequisites of the experiment and overview. We have recap for arrays. It gives a detailed explanation on what are arrays with pictorial representation, as well as time and space complexity of arrays. Under recap of linked list, there is explanation on the linked list concept along with pictorial representation of linked list, and also time complexity. There are a few MCQ based questions available under pre-test. So one can attempt these questions to test their understanding about the concept about stacks and queues. And the stacks, we can see subsections available. So there is aim given in the under the concept. We can see a video explaining what are stacks, stack operations and application, and also push and pop operations of stack. That is well explained in this video provided here, so one can just go through this video also. And under the demo part, we can see instructions given here above, so one must go through the instruction and just follow the instruction. You can see the demo, how the push and pop operation works. You can even increase the speed or decrease the speed of the animation. You can even pause and also reset. So the instructions are given to explore the demo. And under arrays practice section, we can see an empty array is given. There are instructions given, and three buttons are available: push, pop, and clear. So using the buttons, we can try the operations of stack, that is push and pop, and we can use pop also, and also clear to clear the array. So this is how the practice section works. And under time complexity section, we can say explanation is given on time complexity of stack. Same way, the practice section works for linked list. In the exercise part, there is a question given that we have to arrange the numbers given in stack A. With the help of stack B and the four buttons available here, we have to arrange all these numbers in proper ascending order and display the answer under observations. So there are instructions given how we can proceed with this question. So we have to first go through the array, find the least element, and arrange the numbers in ascending order. So I can see 1646 is the least element, so I have to pop all other elements from it and push that to stack P. So I can just use this button. The least element is at the top of stack A, so I can just pop from there and display to the screen. The least element is from stack A itself, so I have to pop the above element into stack B and pop from A. Next is from stack B. Next from stack A. Next from stack B. Next is from stack A. Next are in proper order only, so I can just pop from stack B. I hope I have arranged the numbers in proper ascending order. That I can check by clicking on submit button. It says correct. So it says my answer is correct, and we can even try other set of questions. These are just random numbers. We can even reset our execution at any point of time by clicking on reset button. So three buttons available here and four buttons are available here to solve this question, and also instructions available. So this is the exercise part. And in the quiz part, there are a few more MCQ based questions. So one can just attempt these questions to test their understanding. Informations related to the questions given here are already given under different sections. So you can just one can just go to that. Same way how we had for stacks, we have for queues also. The aim, concept, demo, complexity, time complexity, practice sections, exercise sections, everything is given. And under the analysis part, there is comparison of stacks and queues is given with pictorial representation, and also application of stacks and queues are given. This is under analysis part. So in the posters, we can see a question. And under further readings and references section, we can see few web links are provided that the team have referred while developing this particular experiment. And one can just go through these links also. And there are few MCQ quiz links also provided for stacks and queues. So one can just go through these links. And under the feedback section, after you have gone through this experiment, if you find any issues or any improvements need to be done to the experiment, you can just share your experience here so that the team can fix the issues or update the experiment and you can use it later. So this is how feedback works. And You can see different like many lists of experiments are available under data success lab. So one can just go through all these experiments, and we have two more lab for data structures, so one can just go explore those also. I will just show one more lab, Python programming lab developed by IIT Kanpur. You can just click on the link. The interface is similar to the last lab I have shown. So there is introduction, objective, and under list of experiments we can see around nine experiments have been listed. All these are the concepts that we come across while doing Python program. Different string methods, loops, concept, data types, arithmetic operations, etc. And there is target audience, course alignment, and feedback section also. So under list of experiments I'll choose strings for the demo. So this is the interface where the aim is given in the theory part for the string methods. They have given clear explanation on the string methods that we use, like concatenation, slicing, repetition, with proper examples. So one can just go to the theory part to understand the code properly. And under pretest, we have MCQ based questions related to Python program string methods. And under the procedure, there are step by step instructions given how you can explore the simulator. And there are few more questions available under post test also. And we have references and feedback section. So I'll just go to the simulation part. This is the interface. First part is for demonstration is for giving the input to the program and to control the simulator. And step execute is to display the program, and result section is for displaying the output. So we have four methods available here: concatenate, slicing, reverse, and repetition. So one can just choose one of the string methods, that is concatenate. I've chosen concatenate. And in the first panel, we can just give the input to the program. There is option for optional string. We can just click on start. That will display the Python program for this particular concatenate method in step execute panel. And after that, we have to just go on clicking next button. That will trace the program. And once the program execution is complete, we can see the program output is displayed in result section. So we can even reset the input section and try out with different set of inputs. So similarly, we can just go for other method, other string method. Just click on start, next. That will display the program output. You can try for other set of input also for this particular method. So this is how most of the experiments available under Python program works, and the panel interface is similar only for all the experiments available. So these are the labs available under computer science. So one can just go through all these labs. So as Shashamam told, there is one more link available that is for labs under development. So this is the one. We can just click on the link and the page opens here. We have like approved labs and labs under development. We can see list many labs available for CS also. We can just sort it by clicking on discipline. We can see introduction to PHP, database lab, computer graphics lab, networks, natural language processing, etc. Available under approved labs, and under labs under development. We can see few more labs for CS. Around 8 or something we have lab for CS. So one can just go through all these links also. So it's available in the main site itself. You can just click on the link here. So this is about the computer science labs and the virtual labs. With this, I'm going to stop sharing my screen, and I'll end my part. I'll hand over the session to my next presenter, Thomas. Thank you, everyone. I'll stop sharing my screen. Over to you, Thomas.
Hello, is it audible?
It's audible, sir.
Yeah, you're audible.
Uh, my name is Thomas Alvin. I am a junior research fellow at Center for System Design and NIT Surathgal. Today I will be giving a demo about labs under mechanical engineering section. Now I will be sharing my screen. Is the screen visible? Yeah. In the vlab.co.in website, most of the labs under mechanical engineering section can be found under the broad area of mechanical engineering section, and the labs common to mechanical engineering and civil engineering can be found under civil engineering section. The labs such as fluid mechanics lab, fluid machinery lab, and strength of the materials lab can be found here. And other labs under development can be found under the VLabs dev site. Under the Explore Lab section, in the Approved Labs, when we sort by discipline, we can see machine tools and analysis and synthesis of mechanism labs here. And in the labs under development section, we can find several more labs here. Now I will go through labs under the mechanical engineering section. When we click here, we can see many labs under the mechanical engineering section here. Today I will go through two labs. First, I will go through machine dynamics and mechanical vibration lab by NIT Surathgal. When I click open the lab, we can see a similar interface to the other labs discussed before. We have an introduction, objectives of the lab, list of the experiments. We can see 8 experiments are there, and the target audience, and the course alignment, the main topics included in the lab, and the feedback form to share your feedback. The list of experiment section, first I will go through free vibration of the cantilever beam. We can see the interface is similar to the previous labs, and the aim of the experiment is to find the logarithmic decrement, damping ratio, and natural frequency of the cantilever beam under free vibration. And in the theory section, we can see the detailed theory of the experiment. We can see the variables and parameters included in the experiment. And in the procedure section, we can see the step-by-step procedure for doing the experiment, and we can see the screenshot of each steps of the experiment here. And we can see the formulas needed to find the necessary values in the experiment. And in the self-evaluation tab, we can see MCQ questions we can attempt before going into the simulation. And in simulation, we can see 4 tabs here. EXPR tab means explore, and EXPT is experiment tab. When we go through the explore tab, we can see this interface. Here, user is given the freedom to change the variables and length and mass of the beam under the free vibration. And here we can see the side view of the beam. And when we hover over here, we can see the properties of the beam. Here we can see the cross-sectional view. Here is a spring mass damper system. Here is a animation section. This is the calculation section, and here we can see variable section and control section. We have 2 controls here, one to start and stop the experiment, and one to access the graph. Here we can see 2 graphs here, displacement versus time graph and amplitude versus frequency graph. And in the variable section, we can change the variables such as material and the cross section, length, and end mass here. Here we can see the mass of the system is 29 kgs. And when we change it to other material, we can see the mass and other values are changing with it. When we hover over here, we can see the properties of material such as density and Young's modulus. Here we can change the cross section of the beam, and we can change the length of the beam here. And then mass of the beam can also be changed according to our preference. And the effect of the damping ratio can be demonstrated here now. When the damping ratio is 0, there will be continuous vibration. There will be no decrement in the vibrations. When we start the experiment, the oscillations will not stop and it will go on since there is no damping. And when we see the graph, we can see the continuous oscillations here. And when we apply some damping here, we can see the oscillations will come to stop after some time. And in the graph, we can see the decrement in the oscillations here. In the experiment phase, user is not allowed to change the variables here, and user is given one control to play and pause the animation. And when we click start the experiment, the simulator is showing the graph of the experiment and ask us to find the logarithmic decrement from the displacement versus time graph. Here, from the displacement versus time graph, we can find the logarithmic decrement. We can seek the seeker here to find the displacement at the particular time interval. From the displacement at at each cycle, we can find the logarithmic decrement. When we enter a value here, we can check the result. Now I am entering a random value. If it is the correct answer, it will show the tick mark. We can try again by restarting the experiment. Here the material is bronze and cross section is iron, length is 2170. When we restart the experiment, and the variables will be changing, but the question will be remaining the same to find the logarithmic decrement. And we can restart the experiment multiple times and check the results here. In the second experiment, we need to find the damping ratio. When we click the starting experiment, we can see the graph here. From this graph, we can find the logarithmic decrement by seeking the bar here. And we can find the displacement at the each time intervals, and using this we can find the logarithmic decrement, and from that we can find the damping ratio of the system here. And one more experiment is there. The last experiment is to find the natural frequency of the cantilever beam. In starting the experiment, we can see the graph here, and we need to find the damping natural frequency of the system, and from that we can find the natural frequency of the system here. We can seek to find the results of the displacement here. And after simulation, we can see the assignment section where the student is given 2 more assignments. And the quiz section, we can see more multiple choice questions to attempt. And in the video section, detailed explanation of how to do the experiment is given here. And in the references section, we can see the books which from the experiences are referred from. And in the feedback tab, we can share your experience by clicking the link here. Now I will go through one more experiment. I will go through the electron microscopy for beginners by IIT Kanpur. We can see the similar interface as the previous lab here. Introduction, objectives, and list of the experiments here. We have 10 experiments here. I will go through basics of scanning electron microscopy here. Here the aim of the experiment is given and the detailed theory of the how scanning electron microscopy works and what are the steps to conduct experiments are here. And there is also a video showing the how scanning electron microscopy works. And instead of self-evaluation and quiz, we have pre-test and post-test test tabs here. Then we can test our knowledge before going to experiment in the multiple choice question by attempting the multiple choice questions here. In the procedure, the step-by-step procedure of how to do the experiment is given here. And in the simulation tab, we can hear then audio feedback of instructions to do the experiment. On the right side, we can see a notification of the steps we have done. First, we need to place the material here. And now we need to set the vacuum lever. Set to high vacuum level sensitive metals. We can see the animation of the vacuum here. Now we need to set the acceleration voltage. Once all of it are set, we can turn the beam on. We can see the animation of the beam. And we can see the image from the scanning electron microscope. Here we can change the magnification level. And we can see the result here. And also we can change the brightness and contrast of the image here. And also we can save the image by clicking save image. Now I will reset the lab. And I will do the hair sample. I will do the experiment with the hair sample now. Now we can turn on the beam. You can see the animation of the beam here. We can see the sample of a human hair through the scanning electron microscopy here. Can change the magnification and brightness. To see the results here, we can save the image also. Similarly, we can explore other labs in the mechanical engineering section, and we can find the video lectures of the NPTEL here. Now I am ending my session and handing over to the next presenter here.
Thank you, Thomas. I'm Mahima, working as a JRF in Center for System Design, NITK. I'll start sharing my screen. Hope my screen is visible. Is my screen visible?
Yeah, visible, ma'am.
Thank you. Thank you. So this is the web page of Virtual Lab. Under broad areas of Virtual Lab, these are the domains under which I'll be explaining the lab, which is similar to mechanical and civil engineering, that is strength of material lab, which is developed by NITK Surathgal. So on the left hand side, you can see the tabs of introduction, objective, list of experiment, target audience, course alignment, feedback. So under objective and introduction, you can see the introduction to strength of material lab. These are the objective, and under list of experiment, there are around 14 experiments, which I'll be showing direct shear test on mild steel rod. So under theory, you can find the theoretical background of this particular experiment with the formula derivation. You can go through before conducting the experiment in order to improve the knowledge. And under procedure, you can find the step procedure for while doing the simulation part. Under self-evaluation, there are around 4 to 5 questions which you can go through before conducting the experiment. Go to simulation part. So this is the experimental setup of the experiment direct shear test on mild steel rod. First step, we need to find the diameter of the rod. So arrow mark shows what has to be done. So it is showing to click on the rod. So when I click on the rod, the dia of the rod will be measured. That is 0.06 mm. Again, the mild steel rod is placed in the shear attachment. Now on the machine. So when you're on the machine, you can get the failure load, that is P is 1700 kg. Once you get the load of it by pressing the red button. So using the formula, calculate double shear strength. Similarly, there are 2 to 3 trials. Same procedure is followed with the varying diameter. Here the diameter is 5.95 mm. Place the mild steel rod to shear attachment. on the machine and not on the screen.
If it is audible.
After conducting 3 trials, you can just calculate the double shear strength using the formula. So for time being, just I'll put some random values. Then when I click on check button, the correct answer and the actual, what is the actual value, and the value which we have entered will be displayed. So this is the simulation of direct shear test on mild steel. After simulation, there is some assignment question for assignment question. And under quiz part, you have 4 to 5 questions, multiple choice question. You can go through it after conducting the experiment in order to test the knowledge. And there are 2 videos, that is experimental demo video and simulation demo video. Experimental demo video is it is a video which we conduct in physical lab, and simulation demo is the simulation part which I have shown now. If you have any doubts regarding while doing the simulation, you can go through this video. And there are some references which we have gone through. Can give you a feedback in feedback section. So this is about direct shear test on mild steel experiment. I'll demonstrate one more experiment, that is tensile test on mild steel rod. Same here we have theory, aim, procedure, self-evaluation, videos, quiz. I'll go to simulation part. So this is the experimental setup. First, we need to measure the diameter. Second diameter DIY, and the average initial diameter, that is 12.6 mm. Measure the length of the specimen. So okay, here we can get the length of the specimen, that is 186 mm. Punch the mark at the distance of 2.5. So arrow indication is showing to press on this hammer. So when I click on this hammer, the rod gets punched in the distance of 2.5 D. So done with punch of mark. Next procedure, insert the specimen to its position. Just click on this handle. Now drag the specimen and place it over here. Then mount the extensometer on a specimen. First, we need to make adjustment to 0. Then on the machine, press on the green button shown. Meanwhile, you can get the table of reading. Extensometer reading and ivory scale reading. Press on the stop button. If you want, you can download the data here. Here we can see the graph. So when you click on view data, you can get the table and can see the graph also. This is the graph of load versus ivory scale reading. Similarly, load versus extensometer reading. Here, if you press on view slope, you can get the slope here. Next, join two pieces to measure the dia. And click on this, the diameter gets measured. This is the final diameter. And measure the length, just click on this. Now you can get observation and calculation. Where when I move my cursor on this box, the formulas will be displayed. So you can get the observation under this by clicking on that button. These are the observations. Using this observation, you can go to the calculation. For timing, I'll just put some random values. So when I click on check button, what is the value we have entered and actual value, what is the actual answer, that will be displayed, and we can get the percentage error, what error we have made. So this is about the simulation part of tensile test on mild steel rod. So there are some other experiment also which you can go through it. So under feed target audience is where these experiments are used under. It is used under UG and PG. These are the course alignments. And under feedback session, you can give your share your feedback here. So that's all with from my end. Thank you.
Ma'am. Ma'am, Siddha ma'am.
Your voice and audio, please.
Hello, sir.
Video and audio.
It's the
That's all from our end.
So today, first we will see what exactly.
Is there any queries you can just ask and ask for here or put up in chat box?
okay. If anybody have your queries, kindly ask to me. Ma'am, actually, I can one query for that.
And then see few demonstrations in different domains.
Don't need this
So
one. It's connected. Hello?
Ma'am, can you hear me, ma'am?
Yes, sir. Am I
Uh,
audible, sir?
Actually, openly that virtual lab is available in there. What is the purpose of our institution and the students for use for the virtual lab? Because openly available for the virtual lab in the website in openly available that. If any specification we available for that for user of our students, ma'am.
Sir, actually, everyone can access the virtual lab, but the advantage is that you will get advantage in ranking and accreditation purposes, and the students in your college can come to the NIT to do the internship, sir.
Okay, ma'am. Okay, ma'am. Thank you.
Any other queries?
This is Sanjit Kumar, Principal, M.A.M. of Engineering.
Yeah, okay, sir.
Thank you for my query is like the use
Sir, you're not audible. I request Professor, anyone, I request everyone to mute their mic.
Sir, SK sir, please switch off for mic, sir. SK,
Mohan can
sir.
remove the.
மதன் சார் நீங்களே மியூட் பண்ணலாம் சார். நீங்களே மியூட் பண்ணுங்க.
Sir, you can continue, sir.
Yes, sir. Whether student need any separate login to access this virtual labs, madam?
Pardon?
Just to access all the virtual labs, whether you
Yes.
give any separate user ID for our students or
No, sir. No, sir. You can just log into vlab.co.in is the link to access to the virtual website. So,
Okay.
yeah, by clicking on the link, you will get the web page of the virtual website.
Okay, we have signed MOU with NIT Surathgal. So,
Yeah.
what are the benefits to us, ma'am?
Sir, for the
We are able to directly log in. What is the benefit
ranking,
of being
yeah,
this
for the
MOU?
ranking and accreditation purposes, it will be helpful. And
Okay.
the students of your college can come to our NITK and do the internship, sir. CSD, that is Center for System Design, will be providing the internship for the students, sir.
Oh, that's fine. Okay. Thank you, ma'am.
Yeah. So, any other queries?
No, ma'am. Thank you, ma'am.
Yeah. So, if no other queries, I thank on behalf of Virtual Lab team. I thank all the faculty members of M.A.M School of Engineering uh, for joining this session, and I request everyone to explore the resources and look up of these resources and introduce it to others as well. And I request every participants to fill the feedback form. And for any queries, you can write to us at solve@nitk.edu.in. Thank you all.
Thank you, ma'am. So very thank you to participant for the all faculty members and respected HODs. Thank you. Thank you to all.
This also stop.